Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In the last episode, we added the geometry component and the logic for material handling in the editor. In theory, we should now be able to add geometry components to a game entity using this drop-down menu. Right now it doesn't do anything since there is nothing attached to it. So let's start by adding a function that creates a geometry component for us. This is the same as for the script component. First, we have to add an enumeration for geometry. We also add a creation function in this array. The geometry component's constructor takes the reference to the game entity and the asset info for the geometry asset. Finally, we add a new case in this switch, where given a component type, it will return the enum value for that type. Now in the code behind of GameEntityView, where we have the component drop-down menu, we can simply copy and paste this method and create a geometry component with a default geometry asset. Then we attach this method to the click event of the geometry menu item. Now when this item is pressed, this method is called, which will add the geometry component here. I'm going to move this converter and put it with the other common converters. In order to display a geometry component in the list of components, we have to add a new data template here, which will display the corresponding component view. Obviously, we don't have a view for geometry component yet, but let me first rename all these component view types so that we don't get name conflicts. Remember that we already have a geometry view in the editor's namespace, which is used in the geometry editor. So by renaming these, there won't be any conflicts. Now one thing that's been bugging me is that we have to do this data context typecast to get the current selection of entities. To make this easier and also make it accessible from classes that are not necessarily related to the user interface, I'll add a new static property that is set anytime a new instance of MS entity is created. Now we can use this instead of casting the data context. Okay, now let's add the geometry component view. Change the namespace so that it's in the editor's namespace. Okay, now the problem is that if you'd name any of the controls that we put within the content of the component view, like here in the transform component view, there's gonna be an error telling us that that's not possible for a reason that I don't understand. In order to avoid this error, I'm going to change this component view to be a proper custom control. So I'll just move it over here to Utilities Control folder and make it inherit from Content Control instead of User Control. Then we won't need a component content property, since a content control already has one that we can use. The class is no longer partial and it has a static constructor where we override the style key metadata. This way we can define our own style for the component view, which we do in the control template XAML file. The style is pretty much a copy of what we already have here in content view XAML file. So here we can add a style and set the template property, where we define what the control will look like. It's just an expander with a header that we can bind to, and the content presenter that will show the actual component. We also add the mouse over trigger that changes the background color. That's all. Now we can delete the old component view control. Of course, we also have to update the namespace everywhere component view is being used. Running the editor, we can see the components showing up as before. Now we can finally work on the geometry component view. Here I'll add some namespaces, and the data context will be the multi-selection geometry. Putting a red rectangle here, we can already see the geometry component being displayed. It seems that one or more uploaded resources are not being unloaded, but that's a bug I'll fix in another episode so that we can focus on the UI side of things. The geometry component view is quite a bit more complex than the other components that we have had so far. This is due to the fact that the geometry can have one or more submeshes in one or more LODs. And I thought it would be fun to make it look different for different number of submeshes and LODs. Let's start with a case where it only has a single submesh and a single LOD. There will be a border that displays the icon of the geometry asset. We can use it to drop a geometry asset in order to change the asset that's used for the component. This is something we'll use in different places, so I'll make a global style that we can reuse. It's a border style where we set allow drop property to true. It also has event triggers for drag enter, drag leave, and drop, so that we can change the border color accordingly. Although we can't test it yet because we haven't implemented drag and drop for the content browser. We'll do that in the next video. However, we can try to open the geometry editor when we double-click the border. There's a private method for this in the content browser view, which we need to make public so that we can call it here. Making it internal does the job as well. In fact, since we are working in a single project and therefore same assembly DLL, we don't need any public methods, classes, and properties. Almost everything could be internal, but that's more typing than using public, so I'll leave it as is. Now we can call this method. Going back to the geometry component view, I add another border that's visible when geometry with materials property is null. This happens when multiple entities are selected with geometry components that use different assets. We use the checkerboard image as the background in this case, and also I'm going to add an image brush that uses a text to let the user know that multiple geometry assets are used. We'll display some extra information next to the border, but only if it's a single mesh in a single LOD. Here we can see the geometry icon and the information. Double-clicking it tries to open the asset. However, it can't be found because it's not registered in the asset registry. So let's do that next. We see the array of default assets here in defaultassets.cs. We can access this array in the asset registry at startup and register these assets. While I was updating the asset registry, I also made it thread safe and added a cache file so that it doesn't have to open and read all asset files in the project at startup. This will speed up the startup time considerably for projects with a typical number of assets. So here I add a lock for synchronization. Someone suggested to use concurrent dictionaries and concurrent collections, which are inherently thread safe. Although that's an excellent suggestion and those collection types are very useful in some situations, in our use case where we have multiple dictionaries, we also want to synchronize their content. So we don't want to access a dictionary while the others are being updated by some other thread, if that makes sense. That's why we lock entire sections of code. As I mentioned, we are adding a cache file with asset information, and it uses this path, which will be set a bit later in the code. This is similar to what we did for content info cache. These two methods should be locked. And we add two methods for saving and loading the cache file. In the save method, we make a copy of the array of assets so that we don't have to hold the lock for too long. Then we basically just write the content of the array in a binary buffer and save it to a file. In the load method, we clear all collections and read from the file. For each entry that we read, if the file exists, we add the asset info to both dictionaries and the array of assets. This way we don't register files that might have been deleted outside of the editor. When reset is called, we load the cache file, which will fill the collections. We do need to know the project path. Fortunately, it's very easy to access since we already have it where the reset method is called. Next, the cache file path is constructed and the load method is called. We call register all assets in order to register any new assets that for some reason weren't already in the cache. We also register the default assets here. We have to modify register assets parameters in order to accept both a file path and optionally an asset info. So if the asset info is not provided, we read the file to get the information. And that's all, I think. I'll do a bit of cleanup and then we can continue with the geometry component view. Okay, now when we double click the cube mesh, it will open since it can be found in the asset registry. I did forget to save the cache file. We call asset registry save method when the project is unloaded. Let's go back to geometry component view. Here we'll have a border with buttons that we can press to apply or reset any changes that we made to material inputs and other properties. I'll postpone this part till we make the controls for materials. We can already add an expander that will hold the material controls. For now, we just display a red rectangle as a placeholder. Well, this is basically how the geometry component view looks like for assets with a single LOD and a single submesh. We'll continue this in the next part, where we'll also add drag and drop capabilities to the content browser. As always, thank you for joining me and I'll see you next time.